Okay, we'll go through a couple of examples here of arithmetic series, sequences, arithmetic sequences. And here's the definition. If you want to copy that down, you can just pause the video. Generally, a sequence of numbers in which the difference between successive terms, the difference between each term, is constant. Okay? So let's look at our first example. First of all, we can check to see whether it is an arithmetic sequence. Okay? We have to check to see if the difference between each term is constant. So the difference between 4 and 10 is 6. 10 and 16, 6. 16 and 22, 6. So we do have an arithmetic sequence here. Okay, so we're going to write two different formulas for it, the recursive formula and the explicit. Okay, so let's start with the recursive. So for the recursive formula, we have to tell the person what our first term is. Okay, so first term, T1, is equal to 4. Okay, so T1 equals 4. Now, after this, we have to tell people, or the person that's going to try to figure out what our sequence is, how to get each term after that. Okay, so we have any term, Tn, is equal to that first term, or the previous term from that, Tn minus 1, plus whatever our common difference is. Okay? So our common difference between each one is 6.
Please excuse the interruption, but the directions that have come to us from Fredericton with respect to the assessment is that all students remain in the class until 11:45. So no students will be dismissed before that time. Thank you.
Okay, so there it is. First term is 4. Any term after that is this previous term plus 6. Okay. Now let's go to the explicit formula. And the explicit formula is always written as T to the n equals, if we want to go back to our original definition, the a plus difference onto n minus 1. Okay. So for us, remember a is the first term, so here our first term is 4. Plus the common difference between each term. 10 subtract 4 is 6. 16 subtract 10 is 6. So it's plus 6 on the n minus 1. So those are the two different formulas that we can write. Now a little bit of math terminology that if you get into university that they might want you to have is you would add that n has to be greater than 1. Or sorry, greater than or equal to 1. We can't have 1 here, we can't say what our first term is. And that n, other than that, can be any natural number. We can't have negative numbers, what's the saying? They all have to be greater than or equal to 1, and because we're not going to have a negative second term. So that's the only thing that reason we're adding that. Now I'll switch the camera over to the other board, and I'll show you another example. And if you can get that one copied down. And we'll give the recursive formula. And we'll give the explicit formula. Okay, for the recursive formula, again, we tell the person what that first term is. T1 is equal to 21. Now we tell them any term you can get by taking the previous term, tn minus 1, and in this case I have to look for what my common difference is. If I go 17 subtract 21, I get negative 4, so the common difference here is negative 4. 13 subtract 17 gives you negative 4, so it's constant throughout. 9 subtract 13 gives you negative 4. Okay, so our common difference here is negative 4, so here instead of going plus 4, you go subtract 4. Okay? So to get any term, you take the previous term and subtract 4. For the explicit formula, again, you go by the general formula. First term is 21 again, so t, the n is equal to 21. Our common difference, as we've already figured out, is negative 4, so instead of going add that common difference, it's subtract 4, and still n minus 1. And again, if you want to be picky about your math and say to the person that if they had no clue what we were really doing here, you could tell them that n has to be greater than or equal to 1 because we can't have negative terms, and that other than that, n is any set of natural numbers. Okay, 1, 2, 3, 4, 5, 6. Up here, it's a little different. Okay? N has to be greater than 1. Okay? We can't have n equaling 1 down here because we've already got the first term. Okay? And we do not have a 0 term to go by. If I subbed in 1 here, I would have a 0th term minus 4. Well, I don't have a 0 term. Okay? So n has to be greater than 1, and then again, other than that, n is any natural number. So those are two examples to go by.